Hi, Assalamualaikum. For this video, my group and I will be presenting our group project for MAT183. We also like to thank Madam Ezzah for the guidance given throughout the process making this video. Before we dive into the business, let me give a quick introduction and insight about our topics. We from class CSC 1102B will be presenting the topics about related rates, which is from chapter 5, application of differentiation. Now, to briefly introduce our group member, starting from left to right is Aiman Haikal bin Zainul, also act as our group leader. Next to him is me, Muhammad Haaziq Aariz bin Kamarul Nizam, following up by Muhammad Haaziq Aiman bin Hafizal and Muhammad Hazim Mirza bin Ahmad Fuzi.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Aiman Haikal bin Zainul, and to start things off, I would tell you about what is differentiation. So, differentiation is a process of finding derivative or rate of a change of a function so that we can determine the maximum and minimum values of particular function. So, in order to achieve this result, there are several techniques that we can use to solve differentiation problems. First, we can use derivative of sum and difference. Second, we can use derivative of rational function, which also known as quotient rule. Next, we can use derivative of a product function, which also known as product rule. So, the rate of function is defined as dy over dx or fx or y. So, there are a total of 5 applications of differentiation. Number 1, there are related rates. Second, we have analysis of function 1, which include increase, decrease, and concavity. Third, we have analysis of function 2, which includes relative extrema, first and second derivative tests. And fourth, we have maximum and minimum problems. And lastly, we have Rolle's theorem and mean value theorem. So, in today's video, our group will present to you about related rates. So, what is related rate? Related rate is a mathematical technique used to analyze how different variables in a problem change with respect to each other. It is often applied in calculus to solve problems involving changing quantities at their rates of change, usually due to respect of their time. So, in a related rates problem, you are typically given the rate at which one quantity is changing and asked to find the rate at which another related quantity is changing. The key idea is to establish a relationship between the variable involved and then use calculus to find the rate of change of one variable with respect to the other. So, there are few procedures that we can follow to achieve this result. First, we must find a equation that relates the two quantities. Second, we then will use chain rule or implicit method to find the answer. So here are some examples on how related rates used in our daily life. For example, filling a container with water. Suppose you are filling a bathtub or a bucket with water from a faucet. The rate at which the water level rises in the container is related to the flow rate of water from the faucet. By adjusting the faucet flow rate, you can control the rate at which the water level changes. Second, how about balloon inflation? When inflating a balloon, the rate at which the balloon volume increases is related to the rate which air is being pumped into it. The larger the pump flow rate, the faster the balloon inflates. So that is a little rough idea about related rates. That is all from me. Thank you.
Okay, so for the problem statement, a scientist wants to find out the time it took to fill the conical water tank. The conical water tank has a radius of 3 cm at the top and 15 cm height. The water flows into the tank at the rate of 6 cm cubed per second. Okay, so for the question A, show that the volume of water is given by V equal to pi h cube over 75. Okay, so for the question B, how fast is the height changing at an instant when the height of the water is 5 cm?
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hazim Mirza. So today I will
present the question 6, which sounds like this. A conical water tank has a radius of 3 cm at the top and 15 cm height as shown below. Water flows into the tank at a rate of 6 cm³ per second. So the info given here is, first, the radius equal to 3 cm. Next, height equal to 15 cm. Lastly, the rate is 6 cm³ per second. So I will do the question 8. The question: show that the volume of water is given by V equal to pi h³ over 75. So we need to show that the volume is like this, over 75. Alright, so first thing that we need to do to solve the equation is we need to know what is the volume of the cone. So the volume of the cone was given in this question, which is, we need to copy down back. Volume of the cone equals to 1/3 pi r squared h. Alright, next we need to make a ratio. The reason we need to make a ratio because in the question it said that V equals to pi h³ over 75. So we need to eliminate, or we need to substitute the R algebra. So the ratio, we will get radius equal to radius over height. So the information given is radius 3 h 15. Alright, then we simplify, we get 1/5. Alright, so therefore R equal to h/5. Then we need to substitute this into the formula given here. Let's do it. V cone equals to 1/3 pi, substitute it, h/5 over 5 squared h. Then we simplify, we expand, and doing all of that things, we will get pi h squared over 75. So it is proven like this, as given, as wanted in the question. So that's all from me. Thank you.
Okay, so for question B. So from the question, we get that dV over dt is equal to 6 cm³ per second. So we use a formula chain rule. So it will dH over dt equal to dH over dV multiplied by dV over dt. But from the question answer that we get from a question A, we only get dV over dH. So we need to differentiate it into dV over dH. So while we differentiate it, for the pi h squared over 75, we will get pi h squared over 25. So we substitute it into dH over dt equal to 25 pi h squared time multiplied by 6. So we will get 25 pi, and h we substitute 5 into h, we get 5 squared multiplied by 6, and for the final answer we will get 1.909 cm³ per second. Okay, that's all from me. Thank you.
Okay, so for the conclusion part, by applying differentiation method in this problem, we can conclude that the application of differentiation can be used to, first, define a value of a volume. Second, solve any other kinds of problems. Third, solve problems related to value of a volume. And lastly, how fast is the height changing at an instance when the height reach
the certain value. So example, I will give you in our real life situation. If you go into he and she example, we can calculate how fast the water will drip into the machine, or how long it will take for a coffee full in a cup. That's all. Bye.